Hello, everybody. Can you hear me okay? Hmm.
Yes, I can hear you.
Yes. Okay, good. Thank you. I just like, it's a long story. I took my whole Zoom apart with different settings and to practice something, and I just put it back together. And I think I have it set correctly. But if anything doesn't look the way you expect, please let me know. Let's start by just saying hi. So if everyone could turn on their camera very briefly and their mics and say hi to everybody. Hello.
Hi.
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 Hi everyone. I have a quick question for you. The question is about music. Today's musical selection was a suggestion from someone in the class. There's a form you can fill out in Canvas to make a suggestion. But what I would like is if you have an idea, if you could type it in the chat and we'll all press return at the same time. So don't press return yet, but I'm looking for music that, sounds like you're in an elevator or a waiting room, but it doesn't make you fall asleep and it's not irritating, right? This should maybe be instrumental, nothing offensive, nothing that makes people anxious, to chill out for a minute so everybody knows if you hear the music, class hasn't started yet. So I'm looking for any suggestions that you have, because frankly, I am out of ideas and I really appreciated the suggestion that was submitted. I think I've probably talked long enough that you can press return. So go ahead and press return. Hopefully some people have some, I like these ideas. Okay, this is amazing. Okay, thank you. I'm just gonna take a little screenshot of this right now so I don't lose it. Okay, saved. Okay, great, thank you. That is extremely helpful. Great, okay, so you can turn your cameras off for a while. We're not gonna need them again until the end, I don't think. Here's what we're going to do today. We're going to talk about the week and what's due this week. We're going to do the reflection in Canvas that gives you the 5 points for being here. That will include watching a video, which I will actually show through the call. The rest of it is just talking about the material for the week. What do you need to know from the sections for this week? What's going to happen to you on the homework? And then we'll have some question time, and that'll be it. Okay, so let's start. Oh, let me show you the calendar. So same week structure that we usually have, except I want to draw your attention to two things in particular. These two things I just put the box around. The algebra boot camp at the bottom, that is still ongoing, but you have till week 7 to hand it in. So I don't think you really need to worry about it this week, because there are two other things. The learning curve is sort of a fun, like gamified quiz and answer thing that's inside WebAssign. It's like part of the ebook, and there's a link in Canvas to how to get to it. You basically answer questions and you get points for getting them right, and then if you get them wrong, they ask you easier questions and they're worth fewer points, right? So and you're allowed to look in the book while you do it, and it helps you review the chapter. You can ignore that if you want to, because it's only for engagement points, but those are pretty valuable points. Like if you end up at the end of the semester just a couple percentage points away from where you want to be, a bunch of engagement points might be enough to save you. It's also just good for you to review. So it's there if you want it. The success assignments, they're mostly they're like a little training almost. They're not math problems. They're like, like watch a video, what is your mindset like, have a small reflection, stuff like that. Very useful sort of study tip type assignments, also worth engagement points. So I recommend doing those also. Oh, I think people may have, I'm not sure if people added something since I took the picture. So I'm just going to retake the picture just in case. Anyway, that's due this week. I do not intend to give any deadline extensions for that assignment, for the success assignments in particular, because you've had them for weeks. Okay, so if you want to do those, that's a good thing. You could just knock down today, so it won't be in your way later. Everything else is pretty normal, except I want to point out almost everyone remembered to fill out the Friday survey if their homework was over 60%. I think only 1 or 2 people did not do so, and so they didn't get the points. But so please remember to fill that out if you want the points. I wanted to point out that that assignment is actually open right now. So if you went and did 60% of your homework today, you could do that Friday survey and it would be done. So the Friday survey is available to take all through the week, but it's sort of due on Friday and it's not expected that anybody will get there until Friday. Um, just so you know. Any questions about the schedule, the calendar for this week? We're doing a good job still having people in person on campus. Nobody's been sent home. Fingers crossed. Okay, so let's do the canvas reflection. This one, I don't put your, you don't have to put your cameras on because this one's a little personal. This is a story from Nancy Pye, who some of you may remember from the videos in our resource documents. So there's already been some Nancy Pye videos, I think, in those resource documents, and there'll be a bunch more throughout the semester. So you may have already heard Nancy Pye talk about math. But in this video, she's going to talk about what happened when she failed a test. And at the same time, you should go to Canvas, go to week 4, go to the Monday reflection, and there's something for you to do there that you have to do by the end of class that gives you, you know, free points for coming to class. Thanks for coming to class. So I'm going to play this video. I believe I have the everything set up right so that you can hear it and see it. If anything goes wrong with the sound or the video, just tell me in the chat, okay? This is about 4 minutes long, and you can do your Canvas assignment while you're watching it, okay? Just again, in case you spaced out for a minute, you don't know what's about to happen, you have to go to Canvas and open your reflection, and you're gonna do that reflection, and then you're also gonna watch this video because that's part of it, okay? Here we go.
Hi, it's Nancy, and today I am not going to explain math. There's something else important I want to talk to you about. A lot of people recently have been asking me if I've ever failed a test. It's usually because the person has just failed a test, they just found out, and they don't know if other people they know have gone through this, and they're looking for any kind of glimmer of hope. Yeah, I have failed a test, and I'm here to tell you about it. Yeah, the high school Nancy, very studious, very book smart, had never failed a test before. And then that economics test showed up. That score, the number. The number itself is shocking when you get the test back. So I look at the score and it's 36. And I was hoping for a minute that that was out of 50, but it's 36%. And I know what percent means. That is definitely out of 100. And then your brain goes to, okay, so if this is my grade out of 100, how does this affect my next test? What do I need to do on my next test or final in order to counteract this? And it's like a numbers averaging thing you're figuring out. Is this hopeless? Should I drop this class right now if I can? You're gonna be doing some math to figure out if there's hope for you to pass. Now, it's kind of ironic doing math to figure out if you can pass your math class. I studied. I thought I studied enough. I didn't think I failed. I felt like I took the test and I had used good judgment and logic in answering the questions, but apparently I was way off. I didn't realize that I actually needed like a better understanding of the, I needed a more, I should have studied harder those concepts. Definitely there's that element of embarrassment, but mostly it's, should I not be in this class? Am I not smart enough for this class? Yeah, that's real. Yeah, once you get past the embarrassment, then there's a bit of anger, definitely at yourself, but at least for me, also at the teacher, because these test questions were so different from the homework practice and from what she taught in the class. And it just feels a little bit like betrayal, like you're blindsided by these test questions, not quite fair. And then when the anger goes away, you're just left feeling kind of stuck. Maybe you don't know how to study differently, or you have a job or a part-time job that just takes a lot of time and you're just overloaded with life stuff or family stuff, or you've got a bunch of other classes that are demanding. And like, how are you supposed to do things differently to not let this happen again? And quite honestly, I was a senior feeling some senioritis. So maybe a little demotivated. That's honest, but like, what am I working for? Why do I need to get an A in this class? No, wait, can they take away your college acceptance if you don't pass that class? Yeah, that's a scary thought. The important thing to remember is that, one, you're not alone. It's not just you. There are a lot of people who just failed, who are worried about failing. There's probably people in your own class who failed the same test. You're not alone. And number two, this doesn't mean that you failed forever. That was just that moment in time. This does not mean that you're not capable of doing that math, that you don't have the ability to do it. No, it was just at that particular checkpoint in time, your progress was there. Case in point, I did not fail the next test. I barely passed it. So I hope me revealing how terrible I was at economics helped you feel better about your math test. Certainly not my finest time to shine that economics class. And hey, if you're having some trouble with math, I know a certain someone who has a bunch of great tutorials on math, is making those math videos now, currently on a lot of topics.
Okay, so you already know that she's doing that because you've probably watched some of her videos before. So please go to your Canvas if you haven't already and do your Monday reflection. Hold on, my headphones are running out of batteries. So the time, please excuse me while I work out my life. I wanted to tell you two more things about this just while we're on the topic. So the first thing is that, oh, somebody raised their hand. Do you want to ask a question?
Slightly off topic, but are you gonna unlock our quiz grades?
Yeah, well, it's kind of on topic because we're talking about the grades. I am, but there is a student who needed just a little more time because of a situation, and so I don't release them until everybody's all done. So we have to wait until tonight, okay? But after tonight, I will release the grades, and also you'll see the answers. And you know, some of you did great, and some of you maybe didn't do so great, and this video will become relevant. Hopefully you all did how you wanted to be, but I can't release them yet. I'm going to release them tomorrow. Thank you for asking that. Okay, so the two things are, first of all, a friend of mine, Francis Sue, very well known in the mathematical community. He gives a lot of talks about grace in mathematics and the human flourishing of mathematics. He's almost like a philosopher sometimes. And one thing that he says that really struck me, and I want to share it with you, is that this phrase that your work is not your worth. Like what makes you worthwhile as a person isn't related to your success on a quiz or a test or a class or college in general, right? Like the people in your life that are important to you, they're not important because they did good on a quiz, right? Like that's not really related. And I just want to remind you to separate your worth as a person from the event of getting bad score on a quiz or needing to do better in a class. I know things can seem really overwhelming, especially if this is your first year and we're all online and there's a pandemic and. So I just wanted to let you know. The second thing is you may have seen, I put an announcement in Canvas that I'm giving this big public lecture tomorrow night because everybody is online. Everybody can go. You don't have to go to Minnesota to go to it. So you're free to go if you like. I wanted to let you know that a lot of the talk is actually really about failure and the process of design and mathematics and how that inevitably leads to failure. It's really talk about 3D printing. So if you want 3D printing, you can go, but secretly it's talk about failure, just in case you want to hear more about that. Okay, so let's talk about what's in the book. So this week we only have one section, that's section 0.7. It's about logic. The rest of the web assignment is about like a review of chapter 0, okay? But so there's only one new section this week. And there's two parts of it that I think are really important. The first is implications, which I'm going to talk about here. And the second is quantifiers, which is the slide after this slide, okay? So here is the deal with an implication. An implication is a statement of the form if A then B, just like it says here. And it's sometimes written, I'll circle this other thing too, as A arrow B, like with a two-legged arrow. Sometimes people say A implies B, but the real key is that implies. So I'm going to write that. A implies B. The important part of the statement is the implication itself. So for example, if the statement A is I put a quarter in the vending machine, and the statement B is a soda came out of the vending machine. The implication statement is if you put a quarter in the vending machine, then we can guarantee that a soda would come out. Now, I know that the machine could be broken, but let's just pretend we're in a universe where the soda machine's not broken, okay? That's like a 2020 thing that happens. 2021, the soda machine is working. Okay, so that means we can guarantee that if we put a quarter in the machine or however much money in the machine, a soda is going to come out, right? If you don't put a quarter in the machine, a soda won't come out. But that doesn't make this statement false. If you don't put a quarter in the machine and then you take a hammer and you bust open the machine so a soda falls out, that doesn't make this statement false either. The only thing that would make this statement false, the implication false, is basically if the machine were broken, is if the first part could be true, you put a quarter in the machine or however much money, and the second part is false, soda doesn't come out. That's what would make the implication false. It's very important to remember that. It's not A and B, it's the fact that A is implying B. So if we look at these statements down here, like this first statement, if X is greater than or equal to 2, then X is guaranteed as an implication to be greater than or equal to 3. That is false. Okay, so this is false. Like, for example, X equals 2 makes this false, but I'm going to use X equals 2.5 because it's not like an edge case, okay? So if X is 2.5, then that makes this first part, if X is 2.5, it makes this first part true because 2.5 is greater than or equal to 2. But we cannot infer from that that X is greater than or equal to 3. In this case, X is not greater than or equal to 3. So it's perfectly possible for the first part to be true and the second part to be false. This is what's called a counterexample. So a counterexample is an example that makes the statement you're looking at false. And in the terms of an implication, that means it's making the first part true and the second part false, okay? So that's how an implication works. We're going to see them all the time, okay? Like most of our theorems are in the forms of implications in this book. Okay, does anyone want to ask about this before I go on to the next slide? Okay, next slide. Quantifiers. Sometimes we want to be very clear about how often we're asserting a statement is true, how often the statement needs to be true for the whole statement to be true. And there's two quantifiers. One is for all, and the other is there exists. And I realize I wrote these upside down and backwards. You might see in a future math course, the upside down A is a shorthand for the phrase for all, and the backwards E is a shorthand for the phrase there exists. We're not going to use them in this class. I'm not going to write them in this class, but I want you to be aware that if you see those fancy things, that's all it means, okay? So we can say that a statement is true all the time with the for all quantifier, or we can say there's at least one time the statement is true with the existence quantifier, okay? So let me give you an example. This first statement right here, this statement is true. It is true that for all real numbers, every single one, this thing on the left, 2x plus 2, is equal to this thing on the right, 2 times quantity x plus 1. We just factor out the 2, right? That's the distributive property, I guess, of multiplication over addition. That's how you would say that. But it doesn't matter. We can factor out the 2, okay? And we can always do that. It doesn't matter if x is 5. It doesn't matter if x is 1,000,000. It doesn't matter if x is 0. It doesn't matter if x is negative. It doesn't matter if x is pi or negative 17.2. It's always true for all real numbers. And because we can't find any instance where it's false, then the quantified statement is true. Okay, here's a different example. I'm going to do this one in red. By the way, earlier, somehow Maya raised her hand. I think there's a little Zoom thing you can do. And I just happened to notice this fleeting little announcement that told me that. And I can't usually see that. So I welcome you doing that, but I also welcome at any moment for you to put a question in the chat or for you to just say a question out loud. And feel free to do the raise your hand thing too, but if I miss it, it means I didn't see it, and you have to like type in the chat or something, okay? Okay, so this red statement, that is quantified by a there exists prefix. And so this is saying that there's some integer for which x is even, some integer x that is even. Not all integers are even. X equals 5 is not even. There are some numbers that aren't integers. That doesn't matter for this statement either. What matters for this statement is that there's some integer x that x is even. That is also true because x equals 2 makes it true, or x equals 4 makes it true. Notice that to make the green statement true, we needed to argue that it was true in every single possible case. If it was ever false, then the whole statement would be false. In the red statement, because it's an existent statement, it only has to be true one time. This has to exist a time that it's true. There exists is like, it's like saying there is one or more. There is one or more integer x such that x is even. That's what there exists is about. Okay. And then those two things get put together. So this part here, oh, I meant to use a different color that I hadn't already used. Okay, this blue part down here at the bottom, this is what's called double quantified. Yeah, those are double quantified statements. There's two quantifiers. For the first one, we have a for all statement followed by a there exists statement. And in the second statement, we have a there exists that's followed by a for all. And if you look at what I underline in blue and in black, the only thing different between the top line and the bottom line is that I switched the quantifiers, okay? And I want to point this out to you carefully because I think sometimes when people process what a sentence says, they think of all the elements of the sentence and they just connect them all with ands. And then it's like all this stuff, it's like a list just jumbled up, right? But in math, you can't do it that way. It matters the order that you write it because you're making an argument, okay? So let's think about these two statements. The first one says that for all real numbers, positive real numbers x, any x you pick, there's some y that is bigger than that x. And the second statement says that there's some y out there such that for every x, y is bigger than that x. So I want you to think about those two statements, and I'm going to ask you to write something in the chat. I want you to write like the truth value of these two statements with a comma between. So you could write like t comma t, don't press enter yet. You could write t comma f. You could write f comma t, like if you think the first one's false and the second one's true. You could write f comma f if you think they're both false. So type that in the chat, but don't press return. That way we'll all go at once. No one will notice that you said the right or the wrong answer. First, this statement and this statement, T or F, comma, T or F. All right, go ahead and press return. Let's see what we got. Okay, so if math were a democracy, then TF would definitely have a serious advantage right now. And I agree, actually. The first one is true, and the second one is false. So in the first one, what it's saying is no matter what positive real number you give me, someone give me a real number, I'll take the first one I see. Positive real number 3. Okay, thank you, Logan. So Logan gives me the number 3. I can come up with a number y that's bigger than 3. I'll just take 4. Now, if Logan had said 11, I would just take 12. And if Logan had said 81 million, I would just choose 81 million and 1 or 82 million. It doesn't matter. I can find something that's bigger than whatever Logan says. Okay, so that means the fact that I can win that game means this statement is true. The second statement is a much different game. In the second statement, what I'm saying is that I can come up with a number y in advance, and then Logan can type any number they like, and my number has to be bigger, right? So I could say like 1 million, and Logan would be like, I don't know, 1,000,005. And then I'd be like, oh, I lost that game because Logan's number is bigger, okay? So I would lose that game. So this statement is actually false. And again, the only thing that's different about it is the order of those quantifiers. This statement at the end here that y is greater than x is the same. In chapter 1, this statement right here, let me circle it. I don't know, this is less terrifying color. Here we go. I was going to circle in red, but I find the red pen so aggressive. Okay, so this statement right here is a double quantified statement with for all first and there exists second, and then a statement. If this statement right here that I put a black star on, if that was an implication, like an if-then statement, then what we would have here in the black box is the kind of statement we're going to be studying in chapter 1. So in chapter 1, we're going to be doing this thing called the definition of a limit, and the definition of a limit is going to involve a for all there exists implication style statement. So if you see that in the homework, a statement that has for all, and then there exists, and then an if-then statement in that order, make sure you can do that problem, because future Laura is for sure going to put that stuff on a quiz, right? Because it's really important, and we need it next week. Okay. What would you like to ask about this situation before I go on? Okay, I'm going to go on, and feel free to interrupt me if you think of something. So here I've got a bunch of statements. This is at polyv.com/Tallman700. If you could go there right now. This is a lot of statements, and I think when I made this activity, I didn't really realize that you have to order them all before you press return. It's kind of a pain. So I am going to just waste some time here while you're doing it, but what I want you to do as usual is I want you to push true statements up and false statements down, and stuff that you're not sure about, I want you to leave in the middle. So just start rearranging those. And while you're doing that, someone asked privately in the chat, how do we identify implications? And I would say you either see an if and a then it's like if the first thing, then the second thing, or if things are written out more in notation, you might see one of those symbols with the double-legged arrow, but usually it's an if-then statement. That's what you're looking for, is an if-then statement. So I know this is going to take time, so I'm just going to drink this seltzer here and think about things. Think about your musical selections. There we go. Thank you for that. We got time, so take your time. Okay, so you should probably press the button now. You've got some things in order, thank you. I'll give you about 10 or 20 seconds to press your button so your votes can get in here. If you're not done, that's fine. Just press it where you are. I know you might not be completely done. Very clear winners here. It's fascinating to watch this thing work itself out. And in a minute, I'm going to freeze it. In just a couple more seconds, I'll freeze it. So press that button if you want your answer to be in there. Oh, I like it there. I'm going to freeze it right there. Okay, thank you for that. So, all right, let's take a look at these. Your homework is going to have a lot of these, okay? Your homework is going to be, a lot of your homework is going to be evaluating true-false statements that may or may not involve implications in different types of quantifiers in different orders, okay? So let's talk about these. These first two at the top, these are both true. I'm glad that these are up here. This is in fact the definition of what it means to be even or odd. For example, the number 10 is even because there's another number that it can be written as 2 times that number. So 10 is equal to 2 times 5. So you can write it as 2 times an integer. So 10 is even. The definition of odd is that you're kind of one off from an even number. You could also use 2n minus 1. That's perfectly good definition. But what is important is that a number like 11 is odd because, again, the number 5, let's just write 2n plus 1, 2 times 5 plus 1, or 11. So that those two at the top, those are great. Notice that those are implication statements, right? And hiding in that implication statement is actually an existence statement, right? It doesn't say there exists, it says there is some, but that is actually the same as there exists. So this is actually an implication where an existence quantifier is stuck to the second part of the implication. Okay, we don't need it to be true for all n, just for at least one n. Okay, this third one is tricky. And I have to think very carefully about this one every time. And it may surprise you to know that this is false. Let me show you a picture. Here's a picture of y equals x squared. And here's that's ridiculous. Okay, hold on, let me do that over again. It has a terrible graph. All right, let's focus. All right, this is supposed to be a graph of y equals x. And where the two intersect is at the point 1, and x equals 1. And what I want you to notice is that when I choose a number that's bigger than 1, the squared graph is always higher than the identity graph, the y equals x graph. So if I choose like 2, then I square it, I get a bigger number, 4. If I choose 10 and I square it, I get a bigger number, 100, right? Doesn't matter what number I pick. If it's greater than 1 and I square it, it gets bigger. But check this out. If the number is, oh, thank you. Yeah, Brendan in the chat says that 1 squared is 1. So even right here, the two are equal, right? 1 isn't 0, and yet 1 squared is not strictly greater than 1. It's equal to 1. But even if I had equality here, that's the one that the 1 would need, the statement's still going to be false, because look at what happens if I choose an x that's between 0 and 1. The square graph is under the identity graph. X squared is less than x here. For example, if x is a half, yeah, thank you. Sammy just said this in the chat. If x equals a half, then x squared is 1/4, and 1/4 is less than a half. The x squared is less than the x. Yeah, 0.5 squared is 0.25. It's easy to forget that. Like if I take 1/10 and I square it, I get 1/100th, which is way smaller. Okay, so if you square a number between 0 and 1, it gets littler, which is weird, but it's true. So when you're answering these true-false questions, you're going to have to think of all these kinds of cases. It's not enough just to pick one number. You have to think of things that you might normally forget, like that there's numbers between 0 and 1, or 0, or negative numbers, right? Okay. Oh, now this headphone is out of juice. Hold on. Let me do this little dance. Sorry. Okay. The next one, this is true. Oh, no, we don't want to do that. Let me make it yellow. This is true. For all numbers x, I can choose another number with y equals x squared. Well, I'll just choose the square of whatever x is. So if you tell me in the chat the number 10 for x, I'll choose y equals 100. And then 100 is 10 squared, and I win. Okay, so in this case, there's actually only one number that I could choose for y, but all that matters is that there is some real number. And again, notice that the word some is playing the role of exist here. Okay, so those are equivalent. You can say either one you like. Okay, this next one, that is actually true. Every number I pick to the left of -2, the square of that number is going to be higher than 4. So if I pick like -3, the square of that number is 9, which is bigger than 4. And you're kind of looking over here on the graph now, right? Like if that's the height 4, and this is -2, It's saying that everything I can plug in to the left of -2 is going to be higher than 4. You can see that in the graph. The graph is a good way to check that you found all the cases in general. This next one, let me make sure I get this right. This one's false. I know there's 3 of them, so I want to find them. Oh, this last one. Let's skip down to this one. I know this one is false. There's no way that I can pick 2 positive numbers and have their product be 0. 2 numbers strictly greater than 0, definitely not 0, and their product is 0. I can't do that. There do not exist any real numbers like that. So this statement is false. And then this statement here that I've just circled, that is also false. And I'm going to erase this crazy graph over here so that I have a little more real estate. Hold on, it takes, I don't really understand how erasing works. And so I kind of am doing my best. Let's see how it goes. Okay, that's fine. Okay, that's fine. Okay, so this statement right here, oh, sorry. Please excuse me while I learn how to use my iPad. Okay, there we go. Right. This statement right here, sorry about that, is actually 2 statements. The if and only if is a 2-directional implication. So it's saying x, y is 0 implies that x equals 0 and y equals 0. And it also is implying the other way. And that's what we have to figure out is right. Does somebody have a question and I missed it just now? No, I don't know what I heard. Okay, never mind. So that's a 2-sided implication. The first implies the second and the second implies the first. Now, in this case, the implication on the bottom is true. If the 2 pieces, x and y, are 0, their product is definitely going to be 0. That's definitely true. But this one here is false. It is not true that if a product is 0, that both of the pieces have to be 0. You saw this on a previous thing. You would have to say or for this to be true, okay? So that direction is not true. In fact, I could choose the numbers x equals 0 and y equals 2, and then the product would be 0, but it wouldn't be true that x and y are both 0. So I can come up with a counterexample, and so this statement is false. And then the very last one, there's one more, is this one here in blue. That is actually the definition of what absolute value does. It takes negative numbers and it negates them. And I just want to be clear, there was a little equal sign here, so I'm going to put it back. This was a less than or equal to right here, okay? So like, for example, the absolute value of -5 is negative -5, which is 5. And that's actually true. Well, I should make that in. So far, all my trues are yellow, so let me keep with that style. Okay, that's also true. I do understand why people would put it so far down, and I want to tell you the 2 reasons I think you may have thought this statement was false. The first reason is that you see this. I know I'm making more and more emphatic arrows, but here's a big yellow arrow, right? And it's pointing at this minus, and your brain or your gut is thinking, this means I'm looking at a negative number and absolute values can't be negative. But that is not what's happening here. This minus is not making x negative. It's flipping the sign of whatever x is. So in my example, x is -5, and then I flip the sign of that, and it produces a positive number. Okay, so this is equal to -x. It's the negative of the thing that I originally put in there. Okay, so that's the first reason. And the second reason is when we write absolute value of x as a piecewise function, the equality is usually on the positive side. And you may have seen that the equality is here on the negative side, and so rejected it for that reason. But it's actually equivalent because when x is 0, both sides of the equality are 0. So I can put this equal sign on either part of the piecewise function I want. Okay. So that one's true. And now I've made like crazy marks all over the page. You can take a picture if you like, but if you notice, it's not easy to figure out how to answer all of these. Okay. You have to really think about it, talk about it. This would be a great time to work with your group and kind of argue about these things. That's what mathematicians do. They argue with themselves and also with other people. Okay. So, I'm sorry. Did somebody want to ask anything about that before I erase it? Okay. All right. So that's pretty much it for 0.7. The rest of your WebAssign has to do with the review of chapter 0. This is a particularly important chapter for us to review because it's kind of like our boot camp, getting everyone on the same page. In the end of the chapter in the ebook is this review section. And in that review section in the ebook, you'll see there's this section on notation. This is basically like the math vocab, right? This is the mathematical vocabulary that you're going to need going forward. So you should look at this list and you should feel like you are friends with everything on this list. If there's anything you look at and you're like, what even is that? Then you need to go review what that thing is, okay? Because we're going to use these symbols as our language going forward, and you need to understand the words that we're saying. These are like the words, okay? So go make sure you know all this notation. The other thing is fractions. Everyone's horrible fear is always fractions. Well, for me, it's arithmetic, but I think that for most people, it's actually fractions. So you should make sure that you can complete all 6 of these blanks. How do you add 2 fractions? How do you subtract them? How do you multiply, divide? What happens? These last 2 are like, what happens when you're dividing, but one of them is a fraction and the other one isn't, right? Make sure you can do these without looking at the book. And then if you want to test if your answers are right, they're all in that one big box, I think at the beginning of 0.2, with all the algebra rules, okay? Make sure you can do that. The other part of the review is just to go back and make sure that you can do the problems that we were doing throughout chapter 0. Just sort of revisit them with fresh eyes and see, what, if you can do them now. They might be easier now than when you first saw them. It's typical stuff like finding out where a function is defined or what its graph looks like or how to solve an equation or an inequality. Something that's not on this page for some reason, but is going to definitely appear on the quiz and you should review is compositions. So compositions in terms of equations, compositions in terms of tables of values, compositions in terms of graphs of values like we did on Wednesday. I'm telling you, that's going to be on the quiz. Okay, so make sure you understand how to do compositions in time for the quiz because something will be there. Okay. As for the rest of these things, I've circled the ones, I think I put all of these on the website. I think that's why they're circled here. This is just a picture from the ebook, but I'm pretty sure all of these are actually in your website or some subset of them I think the most important one is this one. I just put a star there. And that's like when you solve an inequality with a number line or a sign analysis. So, you factor, you see where the pieces are 0, you mark those points on a number line, you check each chunk to see if it's positive or negative, and then you read the interval notation answer off your number line. That process, so important, and we'll be using it all throughout the semester, all the way through the last 2 weeks of the semester, we'll be doing that. Very important that you can do that with a sign analysis, so make sure you can do that. This thing here that, well, I already put a star, so I'll put a heart next to this thing, the thing I put a heart near. That's something we're going to see in chapter 2. It has to do with this thing called the derivative. And this type of algebra that you have to do in number 2 is actually going to happen to us a lot in chapter 2. In fact, number 1 is one of those too, right? That's like a terrible heart, like a mangled heart. Here we go. There we go. So that this first one is also one that we're going to see as a derivative. And then finding domains, that's something that you may not have studied so much in high school. And so you may need to review it more now. Like, what are the equations and inequalities that you actually have to solve in order to calculate what the domain of a function is? If that sentence didn't make sense to you that I just said, definitely go watch the videos and do some examples to figure that one out, okay, about how to calculate a domain. Okay, you'll see all that in your homework. Oh yeah, so let me open the floor to questions. I'll take questions out loud in the chat or in pollev.com. If you're still there and it's easy, you can throw your questions in here. What do you want to ask about? Could be about the material we just talked about, or the quizzes, or I don't know. I'll accept questions about Star Trek, tomatoes, stuff I don't know about, like trains, anything you want. I did not watch the Super. I understand that it existed, but I didn't watch the Super Bowl. I saw little clips of it. It looked exciting. I wish I could talk about that with more authority. Do you consider the school bus color orange? I have to consider it yellow, but I think it's actually secretly orange. I hear that Tom Brady is the greatest of all time because, isn't he really old? He wins like everything, so I guess. But I don't know. I know also I'm supposed to not like whoever this person is, so I don't know. It's too political. I can't answer. I did. I watched Tenet last week. Somebody requested Tenet, and I watched that. And then I had to read an article and look at some diagrams to figure out what happened because it was crazy. My cat's name is Blue. He's not doing anything. He's not doing something very nice right now, but that's what his name is. I do play Minecraft. I've played a lot of Minecraft. My family actually went to the launch of Minecraft in Vegas when it first came out, and they did the big handle, and it went from beta or whatever to the first release. It was awesome. We like Minecraft. I don't know who Mike Wazowski is. Is that must be a Super Bowl person? No, it's just these questions are fun. Watch Triple Giant Cow. No, I have not. Oh, a Matthew 31 Minecraft server would be great. Although I think everyone might come and grief my house because that would not be so good, maybe. But that would be pretty cool. If somebody sets up a Matthew 31 Minecraft server, I will definitely come. No, who's Mike Wazowski? Somebody tell me because now I feel old.
The green monster from Monsters, Inc.
Oh, thank you. I do know who that is, and I don't know the answer. I guess because he has one eye, right? I guess I don't know the answer to that. I have seen Interstellar. That was also confusing. Yeah, these are fun questions. Thank you for asking me these fun questions today. I think that's enough today. And yes, my favorite number is 6. Thank you. Okay, let's all say bye. Let me clear these. These are great. Thank you. And I'm not kidding. If somebody makes a Minecraft server, I'm all over it. Okay, so let's all wave and say goodbye. So say goodbye to everybody. Bye-bye.
Bye.
Bye. Have a great day.
Bye.
Good luck on your homework. Bye-bye.